Well, friends of mathematics, we've done it again. We're talking about section 4.1 and 4.2, and I want to talk about problem solving when we're dealing with these things. Mind you, everything here is going to be in the form y is equal to a b to the t, where a is our initial value, b is our growth factor, and y is our output. T is the number of compounds, or the way that we're measuring time. So, in particular, I want us to think about this classic problem. A substance has 20% decay in 10 years. What is the annual percent decay rate? So I think this is very similar to a web work problem that you have in section 4.1. But the takeaway here is 20% decay in 10 years. That means 80% is left. Well, 80% of what? 80% of our initial value. So on one side of the equation, we're going to have 0.8a, and I don't think that's, once we get there, we can certainly say that's equal to ab to the 10. The first thing we'll do is we will divide by a on both sides. And then to take the 10th root, I'm going to raise both sides to the 1/10 power. Okay, so there we have that. Now, once we have our b value, we have to keep in mind that b, our growth factor, is equal to 1 plus r. And so we have 0.8 to the 10th is equal to 1 plus r. I'll subtract 1. And that's our r value, but that is not as a percent. And so to make our percent, I'm going to multiply it by 100. But unfortunately, this right here is a growth percent. And the reason we know it's a growth is because it's going to be a negative value. 0.8 is less than 1. When I raise it to the 10th, that's going to be less than 1. And so it's growing by some negative percent growth. But we want to know the decay rate. And so what I'll do is I'll multiply that by a -1. As a decay. All right, friends of mathematics, that right there is our takeaway. That is our percent decay rate, and that's an exact value. If I wanted to, I could put it into a calculator and get it, but I expect us to be able to work with exact values when solving these problems. So let's do one more problem, and suppose a population triples in 17 years. What is the exact percent growth rate per year? So we know that this 17 is going to be some t value. We can certainly say ab to the 17. But what tripled? Well, the population did, and so we're going to have 3 times our initial value, a. And that's our setup. We're going to proceed in the exact same way that we did before, dividing both sides by a. 3 equaling b to the 17th power. Raising both sides to the 1/17th. And then keeping in mind that b is equal to 1 plus r, we can say that 3 to the 1/17th minus 1 is equal to r, but that is a decimal value. So our exact answer is 103 to the 1/17th minus 1. And that is r as a percent. And because this is a positive number here, and sure, our population is growing, this is our growth rate per year.